Welcome to Apache CXF Essentials. I'm Jamie Goodyear. Today we're going to take a look at using Apache CXF to build reactive endpoints. Up next. Alright, let's get into this. Reactive programming in Java is a paradigm that's focused on building responsive, resilient, elastic, and message-driven applications that can handle asynchronous data streams and non-blocking operations very efficiently. What we're trying to say here is that when a request comes into the system, we'll keep taking those requests before sending back responses. We're not going to hold for request and response. It's just going to be request, and responses coming back. This is really well suited for high-performance systems that need to be scalable, such as microservices and when we have to do real-time data processing. So let's talk a little bit about non-blocking I/O. Reactive programming enables non-blocking I/O, which means that threads are not going to be idly waiting for I/O operations, like reading from a database or doing some external system call, and waiting for those to complete. Traditionally, we'll have blocking models where every request, will hold a thread for the entire time that something's processing and do that request response lifecycle. In reactive models, however, our threads are immediately released while we're waiting, and that's going to improve our concurrency and our throughput. Because instead of saying like, hey, I gotta get 10 calls coming in, I gotta call one, wait till it's done. Now we're going to have all these calls coming in, and they'll get back those responses when they're available. But we get all those requests are now being served. They're all actually being worked on, so they're all started off. We don't have to wait for that first couple of requests to finish off before even starting to work. So what this looks like when we're programming is that in the traditional model, you'd say, hey, I have some string, I want to get a value for it, and we'd call that endpoint and wait for the response. In a reactive model, you'll say, hey, API call, I'm going to subscribe and wait for you to give me a response. The nuance of this is that I can call the subscribe a whole bunch of times, and if these calls take quite a while to complete, those responses will get back to my clients. But I haven't had to wait for every one of the earlier calls to complete before I can even start to work on the latter calls. So under that original traditional model, let's look a little deeper at this so that we can do that compare and contrast and make things really clear. One of the things that we are working toward with Reactive, we want that better resource utilization. And under the classic model, what would happen is that you'd have requests would be handled by one thread, and then another thread's handling another request. And one of those threads or many of those threads are just idle waiting for I/O to happen. Some threads are going to be busy doing real work. And we can only do this so far until our thread pool is effectively exhausted. That's at some point n. And we all, have probably experienced that. Hey, how many compute cores do I have? What size should my thread pool be for a given system? And we modify that, and how many threads are doing nothing all the time, and it becomes inefficient usage of our system because we're trying to block off a whole lot of system to say this is just for serving these particular calls. And if that's not really active, well, those are still being used, and that's not particularly efficient. Under a reactive model, however, we change things up a bit. We still have incoming requests to our system, but now instead of having a thread per request, we have what we call an event loop. That event loop, that's going to be implemented as either a single or a very small thread pool that handles those incoming requests, but then delegates the work elsewhere. So what we end up having is a very high-speed way of taking requests coming in and then letting all that work happen, and then we'll wait for those responses to come back, but we're not blocking anyone from making a request and holding up resources for that. So from the event loop, we're passing things off to handlers. These handlers are going to be things such as a map call, flat map, filtering. These are all those language features we use to say, hey, for a given group of response objects we have, do some work on it. Or I want to iterate across this and look for, say, if I was pulling all the books from a database, I might be looking for all books by a particular author, and then I can wrap those up and bring that out to a stream and send it back to my user. So what happens after those handlers have done their work, they go to a scheduler. Depends now which model of Reactive we're using, if it's Rx or using Webflux, etc. But that's effectively just the organization of your pipeline, that's what we define in our Java codes, that pipeline of a stream, how it's going to be processed. And finally gets to a subscriber. That's where we do the final part of our job. That's going to be the on next, on error, on complete to say, hey, every book that I get, return this book JSON. If there's an error I have, handle that. On complete, I found all my books. Now I've done my job. The stream can now be effectively closed. From here, we can move on to talking about asynchronous service integration. So when we're integrating to other asynchronous systems, so think stuff like Kafka or a reactive database like Postgre or MongoDB, Reactive CXF endpoints can seamlessly participate in these reactive stream and preserve the non-blocking behavior end to end. So what's really good here is that, say, you're talking to Kafka or you're talking to your Postgre database. If you do this in a traditional fashion, say using regular REST endpoints or so, you'd end up in a scenario where you're saying, hey, here's my request and here's my response. And now you're completely negating the fact that you had this non-blocking back-end resource you're using. If you're calling this with reactive endpoints, however, what happens is that you'll have your request coming in, by HTTP, etc., different ways you connect, and then it'll hit your reactive CXF endpoint. So this is your non-blocking controller. So when you're thinking controller, service level, then resources. Once we're in that resource layer, we can do things like the mapping, the flat map, etc., and go through all these responses we're getting back from our messaging platform or from our reactive database, and then send back that response, and we're emitting that back to the client. So think in the reactive stream, that's going to be on your on next or on error or on complete. We start sending back those responses to our client that's awaiting for, or I should say, subscribed to our channel. Let's talk about how this affects scalability. In a high concurrency application, so that's APIs with thousands of concurrent users, a reactive model can help scale horizontally and vertically without having to face that linear increase we have to do in hardware costs. What we mean by this is that under the traditional model, our thread pool per machine can only be so large and be effective. Generally, it's some kind of a multiplication of the number of available cores and how much memory you have. It can say how many concurrent clients that machine can possibly handle. What we're trying to do here is that for the same set of resources, we can have many more clients for the same set of resources. So here we can see we have, for every one client, we have a thread, and as we hit n clients, that's our n threads, and that's our thread pool size. Any additional client coming in, they're out of luck until resources are freed. Under the reactive model, we keep adding in up to those n clients, but we have a much smaller event loop. So that's making one thread or maybe a very small pool of threads to handle all these incoming responses. And then, as the on-completes and on-nexts occur, we start, sending back responses to those particular clients. But because we're not holding up all of our threads that are available on this hardware, we have more available to provide those responses back and keep taking in more requests coming in. It's not infinite, but we can get more overall through. So that's the big selling point of being able to use this model. With all that being said, let's take a look at a demo we've written using Apache CXF and RxJava. RxJava is just a library for ReactiveX. It's a reactive extensions library that lets us build out all of these flows. Let's take a look in the IDE. All of our code for this demo is on our GitHub repo. Take a look in the show notes below for a link. Okay, so while we're here, I'll just put that link up here on the screen. Let's have a gander at our code. So we've set this up as a very simple introductory demo. We have a API, a config object, and our application. So let's start this out with showing you that we are building a Spring Boot application. Classic, set it up with our demo application class. And then we set up a greeting resource. This is going to be the resource that our clients will be talking to, and we want to expose this resource as a set of reactive endpoints. Our endpoint is going to be set up on greet, and we're going to provide the following endpoints. We're going to have a get endpoint for name that will reply with a single element. So under Rx, what we're going to have is a pair of mols we can talk in. One's going to be a single, similar to like a Webflux mono, where we expect to have one element return. Or we can have what we would call a flowable, which would be very similar to the Webflux way of having a flux, where we expect to have many elements being returned back to our caller. So we're setting up a single where we're going to say we want to greet by name and return back a string. So that's going to be like saying hello world, hello Jamie, hello John, hello Susie. we're going to set up another one, which will be to stream back all these responses. So when we call the stream endpoint, we're going to give back a streaming output. Now we're hard coding this, and we're not talking to a database or some Kafka, but what we are going to pass back is a set of responses. So 1, 2, 3, and we'll get each one of those back on our output stream. We're going to set up a flowable. This one's going to have a set of greetings objects. So our greeting object is just going to be, effectively a piece of JSON that's just going to be a message we want to send back. And we're going to set up one for 1, 2, and 3. And those will be sent back. Now, under CXF, we are setting this up and we're returning this as a streaming output that can be read. So your client will be able to pick this up and just use it. Another endpoint we're passing through here is a plain flowable, where we are just setting up a flowable string and passing those directly back. And then we also can set up a flowable SSE, so that's server-side events, where we're going to be producing event streams. That's typically where you'd use those in case of your you want to have a little UI that every time something's coming up, you want a new card to be displayed on your screen. These events are coming in, and that's going to be controlling things coming up on your front end UI. So with that being shown, I'm just going to go down to our applications. We set up a CXF path to say where our endpoints are living to. We also are using a Maven-based build here, so the very high level, what you need to see in here is that we have our Spring Boot parent. We are going to be using CXF version 4.1.2 and a base of Java 17. We pull in our Spring Boot starters, so we're going to have starter web, and then we bring in all of our CXF libraries. There's different ways we can build this up. We can use the CXF Spring Boot starter. I'm using the pure CXF jars just to have a little bit finer grain control of what I'm bringing in. So I have my JAX-RS, my RX2 extensions, my reactive streams, and my CXF core. I'm also pulling in RxJava 2 for this set of demos, and we're up at the level of Jakarta 3.1 here, and we have Servlet 6.0. So with all those brought in, let's just do a quick build of the project. And we'll see this will build relatively quick. And then we're going to go over to our README here. We are going to use our Maven Spring Boot run to start our backend service. So we're going to see this start up the server. We see the server has been started. And now on another page, I have all these endpoints decorated, so it's easy for us to test them out. So we're going to test first the get on the greet name. So we're going to go to localhost API greet and pass it a name John. And we can see we get a response, hello John, back from the system. We can do the stream call, and we'll see that we'll get the stream of 1, 2, 3. We can come in and do the stream flowable, where we'll get a flow of all these JSON objects. So we get a message for each one of those hellos, so hello 1, 2, and 3. Then we can do a flowable plain, where we just get just straight text back. We're not passing back a JSON object. Finally, we can set this up as flowable SSE, where we're getting a server-side event for each one of those objects. So we'll see data 1, data 2, data 3. Now, on a back-end service, those things will take a few seconds for each one of those to come out. You'd want to have a heartbeat and all that set up on your stream. But effectively, this is just showing you can use CXF with some appropriate libraries and set it up now to start doing reactive endpoints. This is really cool. And with that, we've hit the end of our time for today. I'd like to remind you to please like and subscribe to our channel. If you have any questions about Apache CXF or need help with it, please reach out to Safwar. Have a great day. Cheers.